Students, in this video I am taking the new chapter force. What is the force? Whenever we have to do some work we need force. That means the result of force is the displacement of an object or stopping an object which is moving in position. So according to the definition, the effort that tends to change the position of a static means constant or moving object is called force. Force is a vector quantity. The quantity which is having both magnitude and direction is called as vector quantity. Force is a vector quantity which is having both magnitude and direction. The direction of the force is indicated by the arrow. The direction of force is indicated by the arrow, and its magnitude is given by the formula F is equal to mass into acceleration. Mass, the object on which force acts, we have to take that, and acceleration is the displacement of the body by applying the force is to be calculated. F is equal to m into a. Force is equal to mass into acceleration. Newton is the unit of force in SI system. In different systems, the unit of mass or unit of force is different. In CGS system, it is gram into centimeter per second square. In MKS system, it is meter into kg into meter per second square, like that. So there are three types of forces are generally. One is compressive force as indicated in the diagram A. Other is tensile force indicated in the diagram B, and other is shear force indicated in diagram C. So by observing the diagram A, what is the compressive force? The force which decreases the length. You may observe this force and the top force are trying to decrease the length of the object, or height in this case. Height or length, it is trying to decrease the length or height of the object. That type of force is called as compressive force. The force which try to increase the length of an object is called as tensile force. The force which tries to twist an object is called as shear force. The force which extends the length is called as tensile force. The force which compresses the length is called as compressive force. The force which tends to twist the object is called shear force. As I told, force is a vector quantity which is having both magnitude and direction. Arrow indicates the direction of the force. Let's take the first diagram here. Here the arrow mark indicated from A to B. That means the force is acting from A, and it is ending at B, acting from A to B. In the second diagram, the force is starting from B and ending at A. That means the starting point of force in the second diagram is from B and towards A. In the first diagram, the starting point of force is from A and towards B. So this is the left and right arrow marks used to indicate the force. And in other method, the force is represented by two diagrams. One is space diagram, another is vector diagram. So in the space diagram, as I told, the unit of force is Newton. There are two forces acting at the same point O. One is 60 Newton, another is 80 Newton. And the 60 Newton force is acting from O to P according to the arrow mark, and 80 Newton is acting from O to Q according to the given diagram, arrow mark given. So here the magnitude and direction both are indicated directly in the diagram. Both magnitude, that is 60 Newton and 80 Newton, are the magnitudes, and arrow mark is the direction, is indicated directly in the space diagram. Come to the second diagram, where it is called as vector diagram. Here the arrow mark is indicated as in the space diagram, but the magnitude, you may observe here, the magnitude is not indicated directly, that is not in Newton, but a scale is taken to represent 60 Newton as 6 centimeter. A scale is taken, 10 Newton is equal to 1 centimeter. According to that, 60 Newton is equal to 6 centimeter it becomes, and 80 Newton becomes 8 centimeter. So in this way we can represent the force by the space diagram and vector diagram. So whatever the space or vector diagram, the arrow mark is compulsory, but in case of space diagram, the direct unit of force is applied, that is Newton is applied, and in case of vector diagram, a scale is taken according to the given newtons. In this example, I have taken 60 Newton as 6 centimeter, 80 Newton as 8 centimeter. So in this way we can represent the force. So this force representation is very important because it is a vector quantity having both magnitude and direction. The length of the line gives the magnitude of the direction itself, and the direction is given by the arrow mark. So in this way we can represent the force, and we can calculate the resultant force by using these arrow marks and the magnitude of the force given in the problems. So thank you. Thanks for watching.